Hi, pre-calculus kiddos. I am going to be out today. So that being the case, I wanted to make a video for the two problems that we didn't do yesterday. So we did this one here. And so I'm going to do A and B for you guys to watch today, fill the notes to help you with your homework. Since I'm not here to answer any questions today, we won't take the quiz on Monday. I'll answer homework questions on Monday, which will give you one more day to stomach it. You'll take your quiz on Tuesday then, and then we've got PSAT. Then you'll do your review for the test, which is on Friday. So that is going to be our new game plan for next week. I'm just pulling Desmos up. Here we go. All right, so starting with this problem, we've got f of x is equal to x to the fourth plus x cubed minus 26x squared plus 4 minus 120. Remember, we're trying to factor this, so that means we're trying to find out all of our zeros. I'm going to start with our chart. So what did the fundamental theorem of algebra tell us yesterday about our total number of zeros? So the total number of zeros, it says, has to be equal to your highest exponent, which in this case is 4. And they can be positive real zeros, negative real zeros, or complex zeros. What are complex zeros? Those are the ones that have an I in them, so imaginary numbers. All right, and then from the day before yesterday, we had Descartes' rule of signs that said if you want to know the number of positive real zeros, look at f of x and see how many times does it change signs. So we change signs once, twice, 3 times. Positive to negative, negative to positive, positive back to negative. So I could have 3 positive real zeros or 1. To find my negative real zeros, I'm going to plug in negative x and see what I get, and then look at the sign changes in negative x. So f of negative x, remember if it's x to its even degreed power, the sign will not change, so x to the fourth will stay the same. If it's to an odd degree power, your sign's going to change. So this one's going to change. Even, it's going to stay the same. Odd, it's going to change. Constants never change. So for this guy, I went from positive to negative, stayed negative, stayed negative, stayed negative. So just one sign change. I guess we knew it kind of had to be 1 because 3 plus 1 would give me 4. But doesn't hurt to verify, especially if you're trying to show me all of your work on a quiz or test. All right, so I have to have 4 total zeros. If I look at my first one, I've got 3 positive, 1 negative. That's 4 already, so no complex. Remember, if it's 1, it stays 1. So then my other option is I've got 1 positive, 1 negative. That's 2. That gives me room to have 2 complex. So a bit of a shorter table for this one. All right. Once we know what our options are, then we're going to go back and we're going to look. I'm going to erase this just so we don't get confused. We're going to go back and look at our original, find our possible zeros. So for 120, it's plus or minus 1. 2 goes into that. 3 goes into that. 4 goes into 120. 5 goes into 120. 6 goes into 120. 7, I don't believe does. 8 goes into 120. 9 does not. 10 goes into 120. And it's 10 times 12, right? 8 goes into 120 how many times? There's 1. We're going 15 times. So 15 times 8. It would be 6 times 20. It would be 5 times 60. Is that right? No, Miss Aries, that is not right. 5 times, let's see. Sorry, it's really early. 5, we're going to here twice. Sorry, 24. 5 times 24, 4 goes into 120 30 times. 2 goes into 120 60 times, and then 1 times 120. And holy moly, that is a bunch of zeros. So then our next step, so step 1, make the sign chart. Step 2, find my possible zeros. Step 3, graph this up or see if we can't narrow it down. We're going to try to find our upper and lower bound and do our test on it. So we've got x to the 4th plus x cubed. So x to the 4th plus x cubed minus 26x squared plus 4x minus 120. All right, and when we look at this guy here, it looks like we're just in this region. I'm going to scroll out, make sure it's not doing any double loops or anything. All right, so it looks like we're probably crossing at 5 on the right-hand side and negative 6 on the left-hand side. So we need to go 1 out from that. So let's test the region between negative 7 and 6. I'm going to test for negative 7 being our lower bound, 6 being our upper bound. All right, testing for negative 7. Wow, I didn't know how you write a 7. There we go. 1 for x to the 4th, 1 for x cubed, negative 26x squared, 4, negative 120. We went in descending order, so I did not need to have any placeholders. Remember, if this is a lower bound, I should have alternating signs on the bottom. So bringing down 1 times negative 7 is negative 7, plus 1 is negative 6 times negative 7 is 42. So this is 16. 42 minus 26 should be 16 times negative 7 will be negative 112 plus 4 is negative 108 times negative 7 is something really big and positive, which is good, because we're going to subtract 120 and get a positive number. So it needs to be alternating in signs, and we are alternating in signs. So this is a good, not upper bound, this is a good lower bound. All right, let's test. Okay, so what did we get rid of? Anything that's less than negative 7. So that means we don't have negative 8, we don't have negative 10, we don't have negative 12, or 15, or 20, or 24, or 30, or 60, or 120. Why don't we have all those big negative numbers? Because the lowest it could be is negative 7. So anything lower than negative 7 goes away. Don't have to test it. All right, let's see if 6 is our upper bound. If it's our upper bound, what should we see on the bottom? Hopefully you said all positives, Ms. Harris. That would be the upper bound test. So 1 times 6 is 6. 6 plus 1 is 7. Times 6 is 42. Minus 26 is 16. 16 times 6 is 96, plus 4 is 100, times 6 is 600, minus 120 would be 500, 480. And are all those guys positive? Yeah, betcha they are. So this is a good upper bound. If they weren't all positive, what would you do? You'd say, okay, maybe not 6, let's try 7. If 7 doesn't work, you try 8. Or if it looks like it's not going to work for a while, maybe try 10 and go a little bit further out. All right, so that is our upper bound, our lower bound. So that means anything above 6, and in fact, it can't be 6 because 6 was not a 0. So it can't be positive 6. It can't be any of these guys here because they're bigger than 6. There we go. It can't be any of these guys down here because they're bigger than 6. So that really kind of narrowed the field for us. We're going to go back and take another look at that graph, see if we can figure out an even closer. Like we said, we think it's probably negative 6 and positive 5. So let's start with those guys. Let's put in negative 6. I get 1, 1, negative 26, 4, negative 120. What makes it a 0? If when I get to the end, what should my remainder be? 0. All right, 1 times negative 6 is negative 6. 1 minus 6 would be negative 5 times negative 6. 30 minus 26 is 4 times negative 6 is negative 24. Plus 4 would be negative 20 times negative 6 would be positive 120. So yes, indeed, this is one factor. That's my one negative factor. So that means Well, that one was right. So it wouldn't be any of these negative guys. I can stop there. I know I only have one negative 0. It's negative 6. Now we got to go find either 3 positive zeros or 1 positive 0. From our graph, it looked like it's just going to be 1, and it looked like it was at 5. So let's test 5. I'm going to do it with my remainder polynomial down here. Bring down to 1. 1 times 5 is 5, minus 5 is 0, times 5 is 0, plus 4, 4 times 5 is 20, and yeah, that's another good 0. So I've got one factor, which is x plus 6. Remember, you change the sign when you write it in factored form, and then x minus 5, and then it's multiplied times this guy down here, which is x squared plus 4. This is not factorable further because it's going to give us imaginary numbers. So I know that this is the one that I'm working with, where I've got 2 real solutions, the 2 real zeros and 2 imaginary zeros. So here's part A, where they want you to write it as linear and non-reduced quadratics. Non-reduced quadratic just means you can't factor it further. In B, it says don't write it as linear and quadratics, write it straight as linear. So I want all linear factors. So I've got x plus 6, x minus 5. I need to solve this guy to figure out what my linear factors are. So this would be x squared is equal to negative 4. When I take the square root of both sides, that's x is equal to plus or minus 2i. So I've got x minus 2i, x minus a minus 2i, which is going to be plus 2i. So that's B. Notice how I don't have any squares anymore. They're all linear. And then the last one is, what are your zeros? So negative 6, 5, 2i, negative 2i. And so there's my 2 reals and my 2 imaginaries. And so we're talking about this column here of our chart. So long problems, but lots and lots of good math there. If you have questions, we'll go over them again on Monday. Please ask someone in the room that maybe understands it and have good conversations today while I'm gone.